So today I'm going to do facial landmark detection, and this is kind of like object detection, but not quite. Object detection is looking for features or objects in an image and just putting a bounding box around them. This, on the other hand, is actually trying to use a two-dimensional image of a face to construct a three-dimensional projection of that face. And so the AI has been trained on a number of different images, and then based on those images, it's able to detect based on where objects on the face lie, what those might look like in a three-dimensional space. And then it will give you back a mesh of dimensions that you can then use to superimpose objects on that face or do different things with it. And this is a kind of fun thing to play with because it gives you the ability to do silly things like put googly eyes or lips on the person in the video feed, and the eyes will stay there and synchronize with the movement of that particular face. And if I turn my head, the eyes will move with it, or if I turn my head, then maybe the lips move, or if I zoom in or zoom out, the various objects will also shrink and grow with the image as well. And this is kind of the secret sauce behind a lot of different apps that do those silly kinds of things where you can put different kinds of objects on your face. Maybe it's lips or a beard or big ears or a hat or some kind of scarf or whatever it might be. It's using this same basic technology to enable you to do that. So I'm going to show you the example, and it's going to have just a clean video feed, and then it's going to show you an example of the mesh, and then also the person, me in this case, with some silly things superimposed on top of the face. And then I'll show you the code, and then the code will show you how easy it is really to wire all this up and make it happen. So let's go over to the demo, take a look at that, and then we'll look at code. So everything's loading up now. There's the video stream, and this is just using the API from the browser, the webcam API to stream to the browser. And I'm just capturing the video feed to display here. So if I scroll down a bit, you can now see I have the mesh on top of my face, and it's moving with my face. So if I turn my head, the mesh turns with it, move it down, move up. If I get closer to the camera, it makes the mesh a bit larger. If I back off, it kind of stays over my face. And so you can see all those dots are kind of representing different landmarks in my face, like my nose, my mouth, my eyes, and so on. And each one of those dots has a different coordinate in the array. So I can use that array of dots to kind of superimpose objects where some of those dots might be. So let's go down to the next one, and we'll see a sillier version of this. And this one, I just used two of those points to put these googly eyes on me. And so if I turn my head, the googly eyes kind of go with it. If I move closer or move away, they kind of stay in the same place. Or I turn my head, they might get a little smaller. And sometimes one will go wall-eyed if I try too much. And then if I turn my head, the silly lips will also kind of move with my head as well. So this is just using JavaScript to make all of this happen. So it's happening in real time using just simple JavaScript, and then using the model to detect it. So it's kind of fun to watch and do silly things like this. But you could definitely use this for different kinds of video streaming apps or different kinds of things that you might want to add a little bit of flair to that you're processing with. So let's go and look at the code and see how all this kind of fits together. So let's take a look at the code. The code is pretty straightforward. This one is using TensorFlow.js, and it's using the face landmark detection right there for the model. And so that's loading up that in a JavaScript context. And there's some CSS. I'm using the webcam API and just an output for that. And then this is the output for the dots and then the overlays, which would be the eyes and the lips right here. And then down here, we have all the code that just kind of does the rest of it for us. And so the detect landmark is really where all the heavy lifting is done after you wire up the stream for the webcam. And this is then getting the setup for the webcam, and then getting the canvas context. And then it's getting the predictions from the model for the webcam element. So it's grabbing the predictions for the array, and then it's clearing the rectangles for the dots, and then it's drawing the elements on there. It's basically drawing the image on there. And then from down here, if the predictions are there, it goes through and draws the dots on over my face. And then with each one, after it draws the dots, it then draws the particular images for the eyes and so on. So it's just basically getting the coordinates that it needs for that, and then it sets the height and width, and then it draws the eye, and then it sets the angle for the mouth, and and then make sure everything's in sync that way, and then rotates the mouth according to the position and where it's at, and it tries to move it if my head tilts or things like that. So it's just trying to keep everything lined up, and it's just using some JavaScript math to do all that with. Now that part you'd have to figure out, because that's just using the overlay objects, but the actual detection of the features and all that, that's all handled by the model. So what you have to have that back, you just have the overlay that you can easily add, or you can add some of these silly elements like I did. And then you can render the animation with the render predictions once it's done, and it just restarts the loop and keeps doing it until you close the browser. So fairly straightforward demonstration there. It's a little bit more code than the other ones because I'm doing stuff with the overlays that I was doing, but otherwise you still have a fairly easy to use script here for doing silly things like with this, like you saw me do here. So look for this in the video description down below for the link to the repo. And as always, thanks for watching.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up, or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.